day 3, if you guys would turn to page 1 of your exponent notebook, you already have these 4 criteria written down. If you would write down these 2 new criteria. No power to raise to powers and no product to raise to powers. Remember that I will move fairly fast throughout the video. At any point in time, if you need to stop, pause, you can do so. Okay. If you would, you can print out this template, what's above the YouTube video here, or you can just copy this into pages 6 and 7 of your booklet. And I'm going to go ahead and begin. Let's start on page 6, power of a power. Okay, so here's what this says. First of all, let's go ahead and copy that our learning objective. The learning objective says I can simplify exponential expressions using multiplication property. Okay. Let's first talk about what a power of a power is. It means you're going to start with a power, like this 2 to the 3rd here. And you're going to take it to another power. So we have 2 to the 3rd squared. And what that squared means is you're going to take that 2 to the 3rd and multiply it by itself. The 2 to the 3rd times 2 to the 3rd, well, we know from page 4 of our booklet that the product of the power says that we can add those two 3s. So that would be 2 to the 6th. Okay, so what it says here, and copy this down, it says when you have a power of a power, you multiply the exponent. Okay, so the law, the rule here is, instead of having to expand it out like we did here, you can just take the 3 and the 2 and multiply them together. 3 times 2, you get 2 to the 6th. You can see the general rule below it there. X to the A to the B equals X to the A times B. Okay, let's do a couple of examples here. Let's take them over and copy these down. The first example has 7 to the 4th to the 3rd. So here we have a power of a power, where our rule above us just states all we have to do is just multiply the 4 and the 3. So we end up with 7 to the 12th. Now, I've had some questions during class about should you actually have to figure out what 7 to the 12th is. Well, no, that would mean you had to multiply 7 times itself 12 times. So it would be a very large number. So here's usually my rule of thumb. If the number ends up being less than 100, then go ahead and multiply it out. Obviously, 7 to the 12th is much bigger than that. I wouldn't bother doing it. Okay, let's take a look at number 2 here. 3 to the 6th is 0. So we have a power of a power. That states that we can multiply the 6 times the 0. Well, 6 times 0 is just 0. So we end up with 3 to the 0. Now we know from our criteria at the beginning on page 1 that we can't leave any 0 exponents in our answer. You also know that 3 to the 0 is just 1. The last one. X to the 2nd to the negative 4th times x to the 5th. Well, what I've done here is I've actually combined 2 of our rules. The power of a power and also the product of the power on page 4. So which one do you do first? Do you do this exponent that's up here? Or do the multiplication that's right here? Well, what you do is you follow your order of operation, your PEMDAS. It basically states that you'll do your exponents first. So I'll do the x squared to the negative 4th first, and then I'll multiply whatever that is times x to the 5th. So let's see, power of a power, 2 times negative 4 says that I can write that as x to the negative x times x to the 5th. Now this is just a product of 2 powers. Notice you can see the 2 bases, they're both the same, which means we're going to add those exponents. So negative 8 plus 5 gives us x to the negative 3. Well, we also remember from our criteria that we can't leave any negative exponents. So you all remember my cheesy story about riding the elevator. Right? Right now that x is in the numerator. We can't leave that negative 3 there, so it's going to ride down to the bottom floor. When it does, it leaves its exponent. So we end up with 1 over x to the 3rd. As of right now, that's probably the hardest problem I can come up with for you. Okay? Let's do a couple of geometric applications. And I've drawn a couple of things here. I've got a square and I've got a cube. So I've got a 2-dimensional problem and a 3-dimensional problem. Label one of the sides of the square x to the 4th. And what I want to find is the area. Okay, so with the area of the square, one way we can do it is we can just say area equals length times width. Okay? Well, that means that we would have x to the 4th times x to the 4th. Another way we can think of this is we can say the area equals, well, since the length times the width is the same thing, we could say that it's just be the side squared. Well, that means we could take x to the fourth and square it. So we could think of this as a product of powers problem or of a power of powers problem. Either way, we're going to get to the same answer. Up here at the top, x to the fourth times x to the fourth, we'll just add those exponents, and we get x to the 8. On the bottom here, x to the fourth squared, that's the power of a power, we would multiply those exponents. Either way, we would end up with x to the 8. Okay? Let's take a look at the one on the right here, the volume. We'll label one of those edges x to the fifth. Since it's a cube, we know that every one of those edges will be the same. Okay, let's see. One way we could do volume is to say that volume is equal to length times width times height. Well, that means that we would have x to the fifth times x to the fifth times x to the fifth. Another way we could think of it is that volume is one of the sides cubed. That means I could take x to the fifth and I could cube it. Either way that you do this, whether they're on the top or the bottom, the top will require you to add up all those 5s and end up with x to the 15. On the bottom, power of a power, it would require you to multiply those two numbers. Once again, you would end up with x to the 15. Okay, let's take a look at the right side, page number 7, power of a product. Okay, let's copy this down. Pause the video if you need to. So what we have is a product. We have an 8x, which is multiplication problem. And we're going to take that value, whatever it is, and we're going to take it to a power, in this case, to the third power. So what that 3 is telling us to do is to multiply the 8x by itself 3 times. So 1, 2, 3. Well, since there are no additions or subtractions in here, this is all just one big multiplication clump, we could rearrange those pieces in any order that we want. So we can put all the 8's up to the front, and we can put all the x's to the back and have 8 times 8 times 8 times x times x times x. Well, 8 to the sum of itself 3 times is just 8 to the third. And x times itself 3 times is just, x to the sum of itself 3 times is just x to the third. The trick is this, or the rule is this. Whatever's inside the parentheses, every single thing inside the parentheses will get taken to that power. So the 8 gets taken to the third power, and the x is taken to the third power. Let's copy down the rest. Notice the general rule here as well. Let's do a few examples. The first example has the product 3x. We're going to square it. So that means that 3x times 3x. Now we can think of it this way, or we can just use our power of product rule and just say that 3 is going to be squared and x is going to be squared. Okay? Well, think about my rule of thumb earlier. I know what 3 squared is. That's 9. So I could write that as 9x squared. Okay? Let's take a look at the second one. The second one has x to the negative 2, y to the first, remember there's a little y there, and all of that to the third power. So I'm going to use my power of product. It says that x to the negative 2 is taken to the third power. Well, that's a power of a power. So negative 2 times 3, that gives me x to the negative 6. For the y, I have y to the first to the third. That's just y to the third. And there's what I have so far. Now remember, just like the problem we did before, I can't leave that negative in my answer. And so if I'm thinking about this riding the elevator, here the x is going to get to travel, but the y is going to have to stay on the top floor. So I'll end up with y to the third over x to the sixth. Okay? Let's do the third problem here. This third problem here actually has a bunch of stuff in the same problem. Here I have a power of a power, I have a power of a product. I'm going to have a product of powers. I'm also going to have coefficients. That's a mouthful. Let's just attack it here. The first thing I'm going to take care of is this square right here. Because of my order of operation. Then I'll take care of that multiplication. Okay, let's take care of the squared first. So that says that everything inside that parentheses will be squared. So 2x to the third times 2x to the third. Okay, so 2 squared would be 4. X to the third squared, that's 3 times 2, that would be x to the 6th. Then, I'll do my multiplication to the 3x to the 4th. Notice there's no additions or subtractions here. This is all just multiplication, which means I get to rearrange this in any order that I want. So I'll put the quote-unquote normal numbers up front, and then I'll put the x's in the back. So my normal numbers here, 4 times 3 will give me 12. And then x to the 6 times x to the 4, if you add those, you'll get x to the 10. Okay, let's do a geometric application here. It's going to be a three-dimensional rectangular prism. And it's also going to tell you that you have a square base. Okay, well the base is over here on the side. Okay, and if it's a square base, if we know that that side is 4x, then we also know that this side down here is 4x as well. So we have our dimensions. Okay, so let's think about the different ways we can do this volume. The volume that you're probably used to is length times width times height. Okay, well, let's go through that. Volume then would either be 4 times x times 4x times 5x squared. Okay. Another way you could do that is to say that the volume, if it's length times width times height, and we know that the length and width are the same thing, we could say just the side of the base is squared times the height of the prism. Okay? So we could basically say that the volume is 4x squared times the height. Okay? Either way you do this, you should arrive at the same answer. For the blue one here, I just rearrange it in the order that I want. So 4 times 4 times 5 times x times x times x squared. Remember that there's little ones here. So 4 times 4 will be 16 times 5. You can just check this with your calculator. I believe that's 80. And then all these x's, you just add up their exponents. That would be x to the 4. With the red down here on the bottom, I would use my product of power of a product, and then I would use my product of power. So I'm going to go ahead and take care of this square here first. Okay. So 4 squared is 16. And then x squared times 5x squared. Well, rearranging these pieces gives me 16 times 5. Well, that's 80. And then if you add the two 2's, that's x to the 4. We end up at the same spot. Okay? Make sure you have this all filled out and you come into class ready to go. This material is getting more difficult, so you can't afford not to do this. Thank you very much.